Welcome to Fun with Relays. This is Professor Wickham.
So I'm going to be working with a relay for the time being. We're going to measure resistances. We're going to check for opens. We're going to get this relay operating correctly. And I'll show you how to do that with a couple of light bulbs and some power. But first of all, we want to know how a relay works. Okay, so the main factor of a relay is to control a high amperage circuit with a low amperage circuit, which means best example would be my ignition switch. I use my ignition switch, which is low amps, to turn my relay on, and once my relay is on or energized, it's going to send power through my relay to my starter through the fuse block. That's how we're going to get our relay to work, and that's the purpose of a relay is to control a high amperage circuit with a low amp circuit. So we're going to look at relays, and all relays are designed this way. Now there are a couple differences, but there are two differences in the relays.
Things you will need to create a relay circuit.
First of all, you need a relay. Second of all, you need something for the relay to run. And third of all, you need power and ground. Okay, so let's begin. As you can see, I've got a circuit set up here on my circuit board and our breadboard, whatever you want to call them. But what I've got is I've got a switch, a fuse, I have a bulb, and I have my relay. Okay, there's essentially two different types of relays. There's a 4-pin and there's a 5-pin. I currently have a 5-pin set up on my board, but I'm only using 4 of the 5 pins. My light bulb, fuse, and switch, and as you can see, my light bulb works with my relay. And I'll show you how to set it up here in just a second. But I'm going to disconnect my relay real quick so we can talk to you a little bit about where all this stuff is and goes. Okay, now this is a 5-pin relay, so if you look in here, you're going to see 1, 2, 3, 4, and 5 pins. Okay, now I'm not going to say all relays are the same, but they all perform the same function. They probably don't look the same. They may fit somewhere different way, so on and so forth. But they both perform the same function. But on my relay, I have a 5-terminal relay or 5-pin relay, and what we can see here. Let me get you in view here. This is my schematic of my relay. I have E, and then there's C, A, F, and D. Okay, so what I've got here, and D and F down here, look like a coil of wire. Okay, don't know if you can see that, but what that is it is a coil. It literally is a coil of wire. All right, inside how a relay works is basically it works off of electromagnetic, it's an electromagnet. Okay, so what's going to happen is I'm going to energize D with power. Power is going to flow through here in my coil, and it's going to create a magnet, and it's going to go through F and ground. Okay, well, basically it's copper wrapped around an iron core, most likely. And when you energize the coil, it creates a magnetic field. Now, if you look right up here with E, you see how it's angled up to C. And then you see that there's a little open right here between E and A. What's going to happen is when I energize my D and F coil, it's going to make this look like a switch. So E actually is going to come down here to A. And then I'm going to have power on E through A. Right now, if I were to hook it up, I'd have power from E to C, and that's it. Okay? Now, oftentimes on relays, they're numbered differently. 85 and 86 are going to be my D and F. 85 and 86 are my D and Fs. Okay, and then 30 is going to be my E. And 87 is either C or A. And then 87A is going to be either C or A. But if it's just a 4 terminal, A is going to be my 87. So in this one, maybe 87A is my C. But this one's just labeled E, C, A, D, and F. Even on the inside of the where the wiring is where it's labeled. But generally, D and F are 85 and 86. E and A is E is 30 in this, and then 87 is A. 87A is C. Okay. So what we're going to do now is we're going to wire my relay in. Okay, so I'm going to show you how I do that. Okay, so I've got power coming in here through this wire. Remember, in a circuit, I've got to go from power to ground. So I'm going to come up here through my wire and into this terminal on my switch. Okay, what's going to happen is I'm going to come through my switch, and then my switch will get turned on, and my power will come out this black wire here. Okay, and as it's coming up this red wire here, it's going to go into my fuse, through my fuse, and out this red wire. Okay, this red wire I'm going to want to go to, according to this, D. I want to go to D. Okay, so I've labeled my boards C, D, F, E, and A. Okay, remember D and F are my relay side, or my coil side of the relay. I'm going to call that the control side. The control side of the relay is what causes the other side of the relay to work. So I'm going to call this the control side, and this the power side. Okay, control side, power side. I've got power coming into my coil side or control side, and then I'm going to have to come out of my control side. Remember, my control side has a coil on it, which means that's going to be the load in my circuit. So I don't need anything else in my circuit. I'm going to provide power to that side of the relay. So I've got ground coming down here. I'm going to stick it in. All right. Now, I also have to have power coming into my E, which is terminal 30 on typical relays. So E is going to be power coming into my relay. When I energize my switch, I'm going to energize these two terminals of my relay. It's going to activate my switch for E, A, and C, and then it's going to bring power out of A. So what I'm going to do is hook A up to my light bulb, and it's going to follow this green wire over here to this red wire of my bulb. It's going to come through my red wire, through my bulb, do its magic, come out of the black wire to ground. Okay, so what should happen is I should have power on the relay. Okay, now the purpose of a relay is to control a high amperage circuit with a low amperage circuit. So the best example would be the ignition switch on our cars. Our ignition switch is actually a low amperage circuit, but our starter motor is a high amperage circuit. So we're going to use a low amperage circuit to control a high amperage circuit. So again, the control side, the coil side of my relay is the low amperage side, and it's controlling the high amperage side. Okay, so how can I tell if that is the case? What I'm going to do is I'm going to test amperage. Okay, remember, I got technically two different circuits here, right? So I'm going to disconnect this circuit. This circuit goes to my control side of the relay. I'm going to go into the board. Okay, and then I'm going to bring my meter over here. And I'm going to move my leads from here to here with the big A, big letter A, to measure amperage, I'm going to rotate this all the way over to the big letter A. If I'm on the wrong thing, it's going to tell me lead and it's going to beep. So I'm going to move it over here to A. Also, something I need to look at and pay attention to is right up here, we're working with DC. It says A for amps and AC, so I'm going to hit the orange button and it goes to DC. Amps, DC. Okay, and I can hit the range button, but this is auto range, so it's going to auto range for me. Okay, so I'm going to take my red lead and go to my wire I just pulled out. I'm going to take my black lead and go to ground. Okay, now my switch is off, which is why nothing's currently working and I have no amperage. Okay, as soon as I turn my switch on, my bulb should come on and my amps should be registering a reading. Okay, as of right now, I'm reading 0.2. I'm going to round up from 0.198 to 0.2 amps. And that's going to be my amperage for the control side. Again, remember the control side controls a high amperage circuit. Okay, now remember 0.2 amps. I'm going to take this apart, bring this back in and put it in the circuit. Okay, my circuit's now working. I'm going to take the other ground wire out, take it off, stick it in the board. I'm going to take the red lead, go into the wire I just removed, and stick it in. Now my circuit's working again. I took my black lead and stuck it back in the ground where I removed it from. And I'm going to look up here at my amperage, and it says 2.0 amps. Okay. Well, now that I've tested my circuit, I'm measuring amperage through the power side of the relay. I'm getting 2 amps, 2.02 amps. If you remember, on the control side or the coil side of my relay, I was only getting 0.2 amps. So I'm going to use a low amperage circuit to control my high amperage circuit. Okay, so, but here's what's nice about this relay is I can hook up another bulb and have a different bulb on a different circuit. Okay, I'm going to come in here to C. Okay, and I'm going to take my black wire, which is it's black. I'm going to go to ground with my bulb. Plug everything back in. Now, the only way I can get this to work is I have to have the switch off and my other bulb comes on. Okay, which is why this is a 5-pin relay. I have another circuit available to me. Okay, so but I'm going to turn this off for a second. That way I can see the board. Okay, as you remember, E is my power, or 30. Power is always coming in, which is why I disconnected here. Okay, now E, according to my schematic, connects to C automatically. Remember, if a switch is drawn in its normal operating position. Okay, so without anything else, the switch on my relay is actually the normal position is to be closed from E to C. Hence the reason why my bulb comes on. Okay, so also, if you notice, I've got my power coming in here at the very top, comes in this wire, and I've got another wire piggybacked off of that one, so I'm running that in parallel technically. Okay, now I come out of this wire here and come down to E. That's my. So now I'm going to show you how to diagnose a circuit. Okay, notice none of my bulbs are working. Okay, and we're using a relay. That's a 5-pin relay. I've got my control side that controls the high amperage circuit. E to A is basically the high amperage circuit. E to C also would be considered a high amperage circuit. In this case, if I turn my switch on, it's going to energize my coil on my relay or my control side, and my bulb is going to light. Okay, I've got power coming into D, going through my control side or the electromagnet, and it comes down to ground. I've got my main power coming in at the very top, comes down here. It goes through the switch, and it also comes out of this wire to E on my relay. Okay, I'm going to disconnect this so we can see. But I'm coming through my relay, and since my control side of the relay has not been energized, my power is going to go through the relay and come out this green wire. It's going to come green wire into my red wire of the bulb, and then through my bulb, out the black wire, and down here to ground. Okay, so like I said, I got power here. My light should come on. All right, and then when I turn my switch on, I'm energizing my relay, and this bulb should come on. And that one goes off. Well, why does that one go off? Remember, on my switch, on my relay, E to C is closed. As soon as I energize this electromagnet, it closes this switch to A, and then E to A is closed. Okay? So that's how I can operate two different bulbs with a relay. Okay, now, again, a relay controls a high amperage circuit with a low amperage circuit. Okay, I'm going to measure amperage again on this side of the circuit of the relay. Okay, my bulb should come on, and right now I'm at 0.3 amps. Okay, the other one was 0.2. I don't know if you can see that all too well, but I'm at 0.3 amps. The amperage through the ignition side, or the coil side, or the control side of my relay was 0.2. This one's 0.3, and then on this bulb it was 2 amps. So that's how I know my relay is working. Okay, now what I'm going to do is show you how my relay works with just the meter and nothing else. So I'm going to disconnect E and A, taking my bulbs out of the equation. Okay, move these out of the way. Okay, they're all out of the way. This power wire needs to be moved too. Move that. Okay, now I'm going to measure resistances now. I got to move my lead back over to the meter, and my meter has to be in ohms. All right, so remember, E to C is a closed circuit when the relay is not energized. So I'm going to go E to C, and what do I get? I get 0.2 ohms of resistance. Okay, what we like to see is a very low resistance reading, 0.1. We would like to see, we definitely want to be below 0.5 ohms. 0.5 ohms is sometimes considered high resistance, and it's going to get us a not so bright bulb in this instance. Okay, so, but when I turn on my switch up here and energize the coil of my relay, this should actually read OL. And it does. Remember, when I energize the coil of this relay, it activates my switch, so no longer am I E to C, I'm now E to A. How do I know that? Well, with my switch on, I have no current through E to C, but I move this lead over to A, and what do I get? 0.2 ohms of resistance. Okay, make sure you label your readings when you do your readings on the circuit board. Okay. Okay. I've got my 5-pin relay set up. I've got a bulb here and a bulb here. Okay. Got my fuse, my switch, and so on. All right. Now, the way the relay's set up, this bulb should be turning on. Not sure why, we'll figure it out. But if I turn the switch on, I'm going to test to make sure this side works. Okay, so I've got power at E, got power coming out of A. Okay, now also my power coming into my control side or the coil side is working too. Now I'm going to verify my concern. This bulb's not working. Well, I'm not sure why, but we're going to use my meter to find out. There's several things we can do. Okay, now I know, because I'm working with a 5-pin relay, I have a wire coming out here at C, have a wire coming in here at E. That's my circuit over in a nutshell. Okay, now something I can automatically assume, I've changed it around from the little previous videos, but I've got my power coming through the fuse, comes through the fuse and out these two wires right here. One comes up to the switch and one comes directly to E on my relay. Okay, that's constant power at E, switched power at D. Okay, now again, I know my relay, I know my fuse is good because my bulb's lit, right? Because I got power coming in back here through my fuse and it splits right here, comes up here through my switch in this wire through my the control side out of ground. Okay, I know that's all working. Got power coming out of my fuse to E, and I know it's going through my relay to A because my bulb's lit. Okay, so I know for a fact that this circuit is good. Fuse, switch, relay to an extent are all good. My bulb's good, obviously, because it's lit. Okay, what I can do now is I know my switch is off, so this circuit's closed, or open, I'm sorry, it's not closed, it's open. This circuit is open. Alright, closed, open. Alright, but now I have power coming out of here. I'm going to show that to you by measuring my voltage. Okay, I'm going to bring my meter down here so you can see it. Take my lead up here and stick it in here, my red lead on my meter, and I'm just going to go to ground. Okay, I have 12 volts on my meter, which means my fuse is good. Alright, now I'm going to do what we call voltage drops. Voltage drops is the best way to verify that you have an issue. For example, I'm going to do a voltage drop between D and F. Okay, do I have any voltage drops there? No. Well, why not? Well, the switch is off, right? If I come up here, I'm going to show a voltage drop because I now complete the circuit. The voltage is dropping across my switch. Does that make sense? My voltage is dropping across my switch because it's open. Therefore, voltage can't get through my switch to get over here. Now, if I come down here, I'll have voltage there. If I move it over here to this side, no voltage. Okay, so again, my switch is working. So what we're going to do is voltage drops. Right now, I want to do a voltage drop on this red wire. This red wire that comes up here to E. Well, first of all, I know that's right, so I'm wasting my time because my bulb came on over here, but nope, no voltage drops. Again, if I put my lead here and go straight to ground, what do I get? I get 12 volts. Okay. Now, I do know, since my relay's working, everything's really working, I'm going to go from E to C. C is the circuit with this bulb in it. Okay, I'm going to go to E and up here to C and check for voltage drop. Nothing. A voltage drop is what everything is being consumed in the circuit. Okay, let's turn this light switch back on. You know, my voltage drop for this bulb, since it's on, it's being consumed by the bulb. The voltage is being consumed by the bulb. I should have a voltage drop. of 11.76. All right, so we know that's working. Turn this back off. Okay, so basically everything to E, I did a voltage drop. My relay's good. I don't have a voltage drop between E and C either. So I'm going to go here to C and check this wire of C. Okay, no voltage drops. Okay, that's good. Okay, now the next thing is I'm going to go from here to this to ground to check ground for voltage drop. Nope, no voltage drops. Okay, now I'm going to come here to here and see what I get. I have a voltage drop of 12. But why is my bulb not lit? Interesting. Okay, to verify my concern, what I'm going to do is I'm going to measure resistance. Okay, now remember, you have to isolate the load in the circuit before you can measure resistance. So I'm going to take this out and take this out. We've already tested voltage drops on the ground, on the power wire and the black wire, and they both tested good. I'm going to come in here, move my meter to measure resistance, and I'm going to stick my lead up here. Now, if this bulb is good, I should get a low ohms resistance, right? I don't. I get OL. I'm playing with my leads, making sure everything's good, testing it, blah, 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 right? I'm making sure everything is good. There's nothing that's going to counteract my reading, but I'm still getting OL, which means since this is isolated, the only thing in this circuit is this bulb. I'm not getting any voltage through my bulb. Okay, now, when I first started making these circuits a few minutes ago, doing these videos, I couldn't get this bulb to lit. I did the exact same process of what I just did and checked it out. Well, not sure if you're going to be able to see up in here or not. Let me see if I can grab a flashlight. Now, you probably can't see it very well, but I don't know. Let's see if I can get in there. Trying. Well, I can tell you this. Now you can see basically that the one lead is higher than the other. This one was disconnected. Okay? So we got to be careful, make sure these are always connected. Okay, so we slide it back in there. And it looks like I still missed it. So we make sure we can get it in. Okay, so the way we test it, so we measure for resistance again, and what do we get? I got 7 ohms of resistance. That's high. Maybe it's not touching, or it's not in all the way. Yeah, I think it was. Measure resistance again. There we go. All right. There may be some heat in the bulb still, so on and so forth. Now that we have resistance, we've got a continuity reading. I'm going to hook my wires back up. Okay. And now my switch is not on because this bulb's not turned on. But if I push this in, I should get a light. And I do. So that was my problem. Okay, so that's how we diagnose using voltage drops and resistances. circuit board problem for you. My power side bulb is working, and the other power side bulb is not. Okay, why is this side not working? All right, this side's working, but this side's not. Well, let's get to it. So, this is where reading a schematic comes into hand. But before we go and do everything, we know that my fuse is working. Okay, my fuse is working because power comes in through here, through my fuse, and out these two wires. Well, one of them comes over here, all right, and the other one goes through my switch. Okay, well, if I turn my switch on, well, why is my light not coming on? I know I have power here because my bulb's working. So I should have power here. Okay, so we're going to do voltage drops to verify why my power is not working on this one circuit. Make sure we're reading volts DC. Okay, our meter needs to be right here with the V with the straight line and 3 dots across the bottom. Okay, this one with the wavy line above it is AC. Okay, and if you also look up here, I don't know if you can see it very good, that says DC volts. Alright, so we're going to do voltage drops. My switch is on, that's off. Do voltage drop up here, and what do you get? I have 0 voltage drop. Okay, means my voltage is not being used here. Okay, come down here to D and F. Remember, D and F is the control side of my relay, which means it should be consuming voltage. It is. It's got 12 volts as a voltage drop. That's where I want to be at. All right. Now, if I look down here, my circuit is A and ground. So I'm going to come over here and check my circuit. This wire, no voltage drops there. Come over here and check ground. No voltage drops there. Okay, I'm going to come over here to E and A. No voltage drops there. But what I'm going to do is I'm going to come up here from A to C. Oh, I got 12 volts voltage drop. Okay, so there's my voltage drops. Okay, I know that my voltage drop is on the relay. Now, does that mean my relay's bad? Not necessarily. We're going to look into that. Okay, so what we're going to look at is we're going to see that my relay has a schematic on it. And I've shown you this before already, but on my schematic it shows that E to C is a complete circuit when this is not energized. Okay, when I energize D to F, E to A becomes a complete circuit, and then E to C is open. Okay, now what that means is, if you can look, this little switch means it's coming down to A, which means power must start at E. Okay, this on traditional relays is labeled 30. E is 30 typically. Okay, D and F is 85 and 86, and C and A are going to be 87A and 87. Okay, so my theory is I may have something wired wrong. My relay may not be the problem. I may have something wired wrong. So I'm going to set this back down here. I didn't do anything right now, so I'm not going to test anything else out. And what I'm going to do is I'm going to look at how I have it wired. Okay, so according to the schematic, I should have 30. E should have my voltage coming in. Okay, which means if I take my leads here Put my lead here in E and go to ground. I should have voltage, but I don't. Okay, well, let's look at it. Where does E go? E, right here is my wire. It comes over to my bulb. Wait a second, my power should be here at E, and it's not. Okay, well, what's happened is I wired it incorrectly. Pull C out because C's got my power coming in, but C should have power going out. So as soon as I swap those wires, turn my switch back off, ta-da! There's my problem. I just had these two wires mixed up. Okay? Back to functioning correctly circuit.